Hello my dear students, let us continue with the next type of footings, that is strip or continuous footings. A strip footing is another type of spread footing which is provided for a load bearing wall. A strip footing can also be provided for a row of columns which are so closely spaced that their spread footings overlap or nearly touch each other. In such cases, it is more economical to provide a strip footing than to provide a number of spread footings in one line. A strip footing is also known as continuous footing. These are in long strips, especially for load-bearing masonry walls or reinforced concrete walls. However, for load-bearing masonry walls, it is common to have stepped masonry foundations. You can see here, this is a picture of strip footings. The strip footings distribute the loads from the wall to a wider area and usually bend in transverse direction. Okay, these are the load-bearing walls, and through the wall the load is distributed. Accordingly, they are reinforced in the transverse direction, mainly while nominal distribution steel is provided along the longitudinal direction. This is also a plan and section of a strip footing. This is section 1-1, critical section of bending moment for RC wall. This is critical section for bending moment for masonry wall, and this is critical section for one-way shear. This is the length of the footing. So next type is mat or raft foundation. A raft foundation is a solid reinforced concrete slab covering entire area beneath the structure and supporting all the columns. Such foundation, due to its own rigidity, minimizes differential settlements. Raft foundation is preferably used when the column loads are heavy or when the safe bearing capacity of soil is very low. In places like seashore area, coastal area where the water table is very high, when the columns and walls are so close that individual footings would overlap or nearly touch each other, when the when the area covered by the footing is greater than 50% of the total planned area, the mat or raft foundation is recommended. It is most suitable foundation when the soil at its site proposed for the construction of a structure is soft clay made of ground or marshy land with low bearing capacity. Okay, it is more suitable for the soils soft clay, and also so if the ground is made of marshy land and with low bearing capacity, this foundation is suitable. A mat foundation is constructed of RCC slab covering the whole area of the bottom of the structure. The slab is provided with the steel reinforcing bars in both directions. When the column loads are heavy, the main beams and secondary beams are provided monolithically with a raft slab. These are special cases of combined footing where all the columns of the building are having a common foundation. Okay, this have this type of foundation having one common foundation. Okay, for all the columns together. Normally, for buildings with heavy loads or when the soil condition is poor, raft foundations are very much useful to control differential settlement and transfer the loads not exceeding the bearing capacity of the soil due to integral action of the raft foundation. A raft or mat is a combined footing that covers the entire area beneath a structure and supports all the walls and columns. When the allowable soil pressure is low or the building loads are heavy, the use of spread footings would cover more than one half of the area, and it may prove economical to use mat or raft foundation. It is a large slab supporting a number of columns and walls under entire structure or a large part of the structure. A mat is required when the allowable soil pressure is low or where the columns and walls are so close that individual footings would overlap or nearly touch each other. Mat foundations are useful in reducing the differential settlements on non-homogeneous soils or where there is large variations in the loads on individual columns. There are some drawbacks of raft foundation, that is, sometimes mat foundations need heavy reinforcement in certain areas, which can add up to the price of the manufacture. And also the edges of the mat foundation, if not properly taken care of, may erode with time. However, when maintained well, these edges can last as long as the building it supports. Sometimes the design can become very complex and thus requires really skillful and experienced engineers as well as workers. Frost can have an adverse effect on the mat foundation. So this is a picture of a mat or raft foundation. This is a ground and screed, insulation, APM, consolidated hardcore, raft foundations with steel reinforcement bars. You can see here, it's one single foundation for all the columns and walls together. See here, you can see here. See here. These are the rafts. You can see here one single, it looks like a slab, single foundation for all the columns. Okay. These are the columns and this is a raft. Flat plate thickened under columns. There are some methods to find out conventional method and buoyancy type. You just remember this formula. Q ultimate is equal to Q extra load plus gamma into dF. Okay, gamma dF is equal to 5.4 and Q ultimate is equal to, that is same thing, Qx plus extra load equal to gamma into dF. This is just, you remember, it's not so important. You can see here, these are the foundation designs of raft foundation. Raft foundation is also used for a floating foundation where the weight of the structure and raft is compensated by the weight of the soil excavated. Next, let us discuss about the depth of foundation. All types of foundation should have a minimum depth of 50 centimeter as per IS 1080/1962. Okay, all the types of foundation should have a minimum depth of 50 centimeter. This minimum depth is required to ensure the availability of soil having the safe bearing capacity assumed in the design. Okay, this minimum depth is required, should ensure that the availability of the soil should have the safe bearing capacity which is assumed in the design. Moreover, the foundation should be placed well below the level which will not be affected by seasonal change of weather to cause swelling and shrinkage of the soil. This care has to be taken. The foundation should be placed in such a level such that the soil should not be affected under the seasonal changes, like it should not swell, also it should not shrink also. Further, frost also may endanger the foundation if placed at a very shallow depth. Rankine formula gives a preliminary estimate of the minimum depth of foundation and is expressed as D is equal to QC divided by gamma into 1 minus sin phi divided by 1 plus sin phi whole square, where D is minimum depth of foundation and QC is gross bearing capacity of soil and gamma is density of soil and phi is angle of repose of soil. Though Rankine formula considers three major soil properties, QC, gamma and phi, it does not consider the load applied to the foundation. However, this may be a guideline for an initial estimate of the minimum depth, which shall be checked subsequently for other requirements of the design. Next, let us discuss about contact pressure distribution. Both from observations as well as the analytical studies from theory of elasticity, it is known that the pressure distribution beneath footing symmetrically loaded is not uniform. Okay, always it is observed that pressure distribution beneath the footing is not uniform. Okay, for figure A and B shows the probable pressure distribution beneath a rigid footing on a loose cohesionless soil and cohesive soil. This diagram A and B, this is pressure distribution diagram of cohesionless soil and this B is pressure distribution of cohesive soil. And figure C shows the usually assumed uniform pressure distribution. Actually, the pressure distribution is like this for cohesionless soil. This is for cohesive soil. But for the design purpose, we consider the uniform pressure distribution. Like this, we assume and we design. When a rigid footing rests on cohesionless soil, the soil grains at the outer edge have no lateral restraint, whereas in center, the soil is relatively confined, resulting in a pressure distribution shown in the figure A. Means at the outer edge have no lateral restraints, whereas the center, the soil is relatively confined. Okay, for the footings on this is about cohesionless soil. In the case of footings on cohesive soil, the edge stresses may be very large. However, pressure distribution may be considered to be linear as shown in the figure C for the purpose of the design of the reinforced concrete footing. Once the pressure distribution is known, the bending moment and shear force in the footing can be calculated, and the thickness of the structural member of the footing along with the reinforcement can be calculated using the usual principles of reinforced concrete. Okay, so this you have to remember mainly for the sandy soil, means for the cohesionless soil. The pressure distribution diagram is like this. This is a column, load is acting here, the pressure distribution is like this. For the non-cohesive soil, so for the cohesive soil, that is for clay soil, okay, the column, the pressure distribution diagram is like this. Okay, but for the design purpose, we assume the pressure distribution in this way. So the foundation assumed to act as a rigid body is in equilibrium under the action of applied forces and moments from the superstructure and the reactions from the stresses in the soil. The distribution of base pressure is different for different types of soil. Typical distributions of pressure for actual foundation in sandy and clay soils are shown in figure A and B. However, for the sake of simplicity, the footing is assumed to be a perfectly rigid body. The soil is assumed to behave elastically, and distributions of stress and strain are linear in the soil just below the base of the foundation, that is shown in figure C. Accordingly, the foundation shall be designed for the applied loads, moments and induced reactions, keeping in mind that safe bearing capacity of the soil is within the prescribed limit. So this is about pressure distribution diagram for sandy soils and clay soils, and this is usually we assume for the design purpose. I hope all of you understood. Thank you.